still need to do is we need to teach founders how to build teams, because quite a lot of them have no.
Okay, the next talk is starting.
So, now.
We good? All right, let me check. Yeah, this is working. Yeah, there's a bit of a delay there. Okay. Hi. Hello. So this is about building a tracker for the International Space Station, or more generally, like satellites. So I work as a developer advocate for a company called Yoto. I don't work in space, but this was an interesting, I guess, thing for me to look at because I don't normally do this. So the talk was International Space Station Tracker, but this is the same process for kind of any sort of satellites, right? So for any kind of project like this, come on, yeah. When you want to make any kind of data-driven project like this, normally what you want to do is first, you need to get the data, then you interpret the data, then you need to show it. And that's kind of what we're going to do. So first I need to show you what I'm talking about. So this is for work. So I work for a place that makes an audio player for children. So I made an interactive card that in real time will tell you where the space station or any other satellite is. And it's all audio, so that's what it sounds like.
All the way up in space, thousands of satellites are going around the Earth. One of the most important ones is the International Space Station. And right now, it's flying over Somalia. It is traveling at over...
Other facts, yeah. So there's quite a lot of things that are required to get there. So the first one is actually getting full screen back on. That would be good. First one is, why are you failing me? Yeah, there you go. First thing is to get the data, right? So I'm doing this via NASA, and they have a bunch of APIs. So there, this is, why are you breaking? Yeah. Yeah, that's fine. All right, yeah, that's fine. Yeah, it's back on. Okay, whatever. So they have a bunch of APIs that do various things, right? The first one, and there's lots, I don't know enough about this, but they do near Earth objects. They do the astronomy picture of the day that's available via their API. They have an exoplanet API as well. And they have the one that interests us called the TLE API. And that goes for two-line elements, which I discovered this not much earlier than you. But basically what it does is it's a two-line element, meaning it's just two lines of text. And this, it's a bit, yeah, it's not super clear here, but anyway, but it's a line of text with a bunch of numbers in it and letters, and each correspond to a few things. So you've got like the line number, the epoch, the catalog number, the classification. I don't know any of these, but what's interesting is because it's such a well-known format that's been going on forever, it's very easy to go from this to interpret the data, as I said, to go from that two-line element to a latitude and a longitude data. And that's, again, the old problem, tried and true. It was really easy to find a way to convert. But then, lines of latitude and longitude is, that's what we have around the Earth, right? The latitudes go up and down, the longitudes go left and right. Longitudes actually start in this country, in Greenwich. So when you go from that data to latitude and longitude, then you can make what you see for a bunch of trackers online. So if you Google ISS tracker, often they look like this. So there's a map with live location of the ISS, and it shows you latitude and longitude. Great. So you go from an API that gives you in real time a text file that then you convert to latitude and longitude, and you have a tracker. But I don't just need to overlay it on a map, right? I need to show the data in the way that I want. And for me, what it means is, what is it currently flying over? Because the latitude and longitude is a bit of an abstract thing. Like if I tell you mine, you're going to be like, yeah, great, I don't know. So by that, I mean which country, which state, and all of that stuff. So in order to do that, there's a bunch of, then it goes from basically like a mathematical problem, meaning I also don't know anything about math, but going from this point, is it in this specific set of polygons? And to get a specific set of polygons representing a country, there's a format called GeoJSON, which again, it doesn't really matter, but that's it. So you can then give it a point of latitude and longitude and say which polygon is it on, and then you can say, okay, it's over a specific country, right? So then when you figure out what country, then you're good. And you can say, oh, it's flying over, as you just heard, Somalia, India, whatever. But then it becomes a bit more complicated if you need to ask it, if the question is it over an ocean? Because then, up until now, there wasn't really a way to say, right, each ocean is its own polygon. There wasn't really this data on the internet. So if you want to make it yourself, you can. But TLDR is, I had to go and find this from a lab, a marine lab in Belgium, that were the only ones that were cataloging, okay, this ocean is this geometry, this sea is this geometry, because it's quite broad, so it would be like, okay, it's not a country, so it's on the sea, but we want to know which one. We want to know, is it the English Channel, is it whichever sea? So they had this data in a less useful format, so I converted it, but now you don't need to do it. But yeah, it's on the internet now. So now that you have all of that, and the next thing you need to do is, come on, I broke my slides. Is to do text-to-speech, which also lots of libraries, websites allow you to do this. I use something called 11 Labs because it's what we use at work. But that's it. Now that I have the latitude and longitude, I know which country or text it's over, then I can add a bunch of text, which is it's flying over this, and then you can add a bunch of facts around it about like its speed and all of that stuff. But that was basically the process, and now that's it. So if I listen to it again, you'll see now, hopefully it's updated live. And
all the way up in space, thousands of satellites are going around the Earth. One of the most important ones is the International Space Station. And right now, it's flying over China.
Okay, and if I fact check myself using one of these ISS trackers.
Real time.
Yeah, there you go.
Wild.
That's it. Thanks. Yeah. That's it. Yeah, any questions, just shout, obviously, because...
Is there any questions?
Yeah. That was a lot of data, but yeah, that's it.
How about
Yeah.
the text-to-speech?
Yeah. So again, I'm using this thing called 11 Labs, which has this somewhat low latency API. So I'm calling this directly. So what happens here is, again, when I go to this URL behind the scenes, I'm calling two APIs essentially. I'm calling the one from NASA, which I showed you, which gives me that 2-line element, and I'm then doing all the transformation from latitude and longitude, and then which country, and then from that, I call another API, text-to-speech. But you don't need to do it via all of this. Once you have the data, you can just use a website or whatever that does text-to-speech for you. There's various ways of doing it, but there's various degrees of quality, because like the voice does sound quite nice and happy, but there's more like free ones that are just more like quite classic AI voices that are a little bit more robotic. But because I'm working on like a product that's for children, we wanted something that's a bit more happy and engaging, not like right now, the international, you know what I mean?
All the way up in
yeah.
space.
So this is why I used 11 Labs.
Going around the Earth.
But yeah, don't have to use them or something. But yeah, that's the whole thing.
I have a question. So what have you thought about doing, like a shipping forecast?
Shipping as in like
Yeah, there's a radio show like early on in the morning on like some of the BBC radio stations where they do a shipping forecast. It's like it tells you where all things are and what hazards to look out for, what space weather
like this,
going on.
yeah. Oh, so is that in space or in the sea?
What weather's going on the sea and all this kind of thing. It's just kind of like funny. It's almost like an opening to the thing.
We could do that. So we have a weather card that works similarly as well, that does exactly that. That does today it's sunny in whatever. So it's a bit more complicated because it has to be where you are now. Because right now this is just one data point. Everyone needs to know where this thing is. But for a weather thing, it's a bit more complicated because you have to figure out, well, you want your weather in where you are, but then someone in London will want their weather and someone in China, whatever. But yeah, but that's the same principle. Yeah, yeah, we could totally do that. I didn't know BBC did that.
Yeah, I used to listen to it a while ago.
Nice.
It's nice. It's quite soothing.
BBC. Is it just called shipping forecast?
The shipping forecast, yeah.
Oh, interesting. Well, learn something. Oh yeah, shipping forecast, BBC weather. Oh, Viking. What's that? Do you know what these are? Are these ships? No.
So these are the different rivers.
Oh.
Keep going.
Cheers. Yeah. Yeah. This is super interesting. Okay. Well, there you go.
There you go.
Yeah.
There you go.
New idea. That's it. I mean, yeah.
Any other questions? Well, thank you, Albert.
No problem. Can I stop sharing? You, yeah.
Alright, you were filming yourself with your camera.
He was filming me.
That one, right? No, not that one. Right.
Yeah, yeah.
excited. An interactive 3D scene based on your input images. So this is something I've done myself today and yesterday, and this is the input images captured on the Gauss is laughing. I don't know if you guys can see. Let me show you some.
Yes, I can hear you. Can you hear me?
would be sweet spot. Like a city, it's not too far. Yeah, but I really like this place. There's a lot going on here as well. And
John,
you know, if you want to go to Mia, for example, like
I need you to
and it's a bit late, you have too much work.
just do that.
I took an Uber and
Yeah,
took
no,
12 minutes.
I need to
So
check this.
good luck doing that in London, right? In London, it takes 12 minutes to go to the tube station from your house normally.
So hello and welcome back to the Open Space Conference. We're about to start our next talk with Peter Haig, talking about a penny for space. I'll let you take it away, Peter. Thank you.
Right, can everyone hear me? Yeah. Okay. My name's Peter Haig. My background is in astrophysics. I currently work in as a scientist in Cambridge, although not in astrophysics. And I've also, in the past several years, been working as an analyst and activist in this space domain. And I want to tell you about a campaign that I've created called Penny for Space. It's inspired partly by an American campaign, which was called a Penny for NASA. And it's quite simple. You just want to say, out of every £1 the government spends, they should put 1 penny towards space, just 1% of government spending. The UK spends about 1.2 trillion pounds a year in total. So this would be a budget of 12 billion pounds. It would be a massive increase over what we currently spend. But people might not realize that. One of the things they found in the Penny for NASA campaign was they had asked ordinary Americans how much they thought the federal government would spend on NASA, and people were coming up with answers like 30% or something. So part of it is to sort of campaign for increased space spending, but also another part of it is to impress upon the public that this stuff on scale of expense I got a great artist called Daniel Raymer who did this pro bono, which I'm very grateful for. So I tell everyone about his great art. So the question is, why should we do this? It's not a particularly good economic time. There's lots of things that governments should spend money on, like healthcare and pensions and things, and they're very expensive. And part of the reason I chose the 1 penny, 1%, is it's an easy sort of mental picture to say, oh, we're only 1% on space. The other 99% can go on all those other great things that governments need to provide. But still, we've got to justify, if you want to spend billions of pounds of other people's money, you need to say why. So the first thing to understand is that the UK really does underspend in space, both in comparison with our ESA partners. I've not checked the last years, but in most years our voluntary contribution has been below that of Italy, I believe. So I think we're the 4th spender in space, even though we are the 2nd or 3rd largest economy in ESA. And we underspend significantly when we compare with the big players, which is the US and China. And so the proposal is we perhaps not immediately. I mean, you don't want to just sort of instantly just hand the UK Space Agency a £12 billion budget. They wouldn't be able to do anything with it. But to target 1% of the same way we target 5% now for defence. And I think we need to expand in 3 discrete areas. The first is we just need to do more of what we're doing already. We need more UK Space Agency, more ESA. I mean, there's some thoughts on how these things will be reformed, but we can just generally do more of them. The second is defense. The world's getting more dangerous. And we've seen with the war in Ukraine how essential space assets are for defense. And how having your own space assets is also very important. there was an incident, I don't know if you recall, a few months ago, where for various Donald Trump reasons, the Americans shut off access to their satellites that we use to target Storm Shadow missiles. So we supplied these missiles to Ukraine, and they couldn't target them because the Americans were unhappy with President Zelensky or something. This is not a good situation for us to be in. I mean, if we want to supply our allies with weapons, we want to be able to supply them with the whole system and not have the mood in the White House determine if they can be used properly. And this is also helps make the case for spending this much to say, well, part of it is going to overlap with that 5% we're targeting to spend on defense. But the third part is the one I want to talk about most, is colonization. It's not something that you're supposed to talk about sort of seriously in terms of government space policy, but it is important. And it's also something that you can't do, in my opinion, through a normal space agency. So this would be a call to set up a parallel agency to the UK Space Agency. And the reason I say that is there's nothing wrong with the UK Space. Well, there's nothing bad about having a science-focused agency, but I don't think a science-focused agency is capable of the kind of long-term big project as colonization, because there's a tendency just to sort of dice everything up between different projects and sort of make all the stakeholders happy. So, so going on from that, then, why is colonization important? Well, at the moment, there is a very fast rate of increase in the amount of mass going to orbit. This graph I made a year or two ago, so the growth rate isn't quite current, but certainly between 2022 and 2024, the rate at which Falcon 9s alone were throwing mass into space was going up at a rate comparable to Moore's law. And it's like doubling time of 2 years or so. And on this graph, I've plotted that the y-axis is, the assumption is that if you can, that at the point when humanity is throwing 10 million tons to orbit per year, or is getting that mass from elsewhere, from asteroids or whatever, it doesn't matter where the mass comes from. But if we have that much mass in orbit per year, then we've reached a spacefaring civilization, and it's all the good stuff about like floating habitats and Mars cities and all that's achieved. So this is just a simple plot of when do you get there at current growth rates. And it's the y-axis is how old you will be at that point. So and the various lines of birth cohort. So I'm close to the orange line. I was born in 1981. And the cutoff of the line is based on actuarial tables. So that's if you don't make it. So this is sort of to show what the chances are you're going to see serious colonization in your lifetime. Now, you may say, well, the growth rate of Falcon 9 is unsustainable. It could drop. It could do, but it would have to drop a lot. And also, it is kind of dropping at the moment. It's kind of reaching the peak of its S curve. But at the same time, you're getting starships coming along. You're going to get Blue Origin and Rocket Lab are launching their vehicles. There's like a half dozen Chinese companies that are close to being able to fly reusable rockets. So there's plenty sort of to pick up the baton and run with it. Now, the reason I sort of make this point is that, I mean, I can make the independent case for colonization. I can say, well, there's a vast amount of energy and resource in the solar system that can be used to improve human life. We can move stuff into space that won't pollute on Earth and all these things. But the case is redundant if it's already happening elsewhere. And the question is not sort of, should it be done? It's going to be done anyway. Is do we want to be part of it? And what I'm saying here is that there's a very good chance it's going to be happening in your lifetime. And even if you don't believe that, we don't always think on terms of our own lifetime. the picture on the left here is my grandfather. He was born during the First World War, and he died around the time Facebook was being launched. On the right is my son. He was coincidentally born about almost to the day 100 years later. And I hope he has a long and happy life. But even without any advances in medical technology, he will expect to be around in the 22nd century. And what I've noticed is that nobody talks about the 22nd century much. If you look back at sort of 100 years ago, people like H.G. Wells was talking about the 21st century and beyond. There was also the cartoons that we laugh about now, sort of depicting life in the future. We even have important people like Winston Churchill talking about how, in the future there'll be lab-grown meat and things that he predicted. So even if you sort of think that the above case is too bullish, I mean, where are we going to be by 2100? And, well, rather, where is humanity going to be by 2100? And are we going to be players in the West? Will we be operating a base on Mars? Possibly even permanent habitation there. And this is going to happen regardless of what we do. I think to bet on this not happening, you'd have to bet on a very large number of institutions failing simultaneously, and it's not going to happen. And the question I ask is, where will Britain be? Where will Europe be? So my position is that we should, our target in this environment should be to build a space habitat. This would be the national goal to which sort of the agency we dedicate to colonization would be focused on over a long period of time, so 20 years or so. It should be in a dusk dawn sun synchronous orbit that's sort of face onto the sun and fairly low, so that it's a polar orbit, so we can get there from the British Isles if we want to launch from Scotland, or maybe make a launch site off the coast of Norfolk or something. That's a useful orbit if you want to do things like on-orbit data centers. And it's also an orbit you can get to interplanetary trajectories from. The windows are a little narrower, but it's absolutely, you can definitely get to Mars if you want, if that's where you end up going from this orbit. So just a quick note on terminology as well. I'm talking about a space habitat here, which I differentiate from a space station in this way. A space habitat is where you can live. A space station is simply where you won't die. The ISS can prevent you dying for a while, but you can't live there. I mean, the health effects of zero gravity would accumulate very rapidly, and even if you could somehow mitigate that, the radiation on the ISS would probably get into iffy territory after about 10 years or so. So what I'm talking about is big, like in the picture, the O'Neill style rotating habitat. And this is, in my mind, is the ideal national objective for us, rather than trying to sort of go to Mars or go to the moon. This is what we need to be doing. So what sort of pushed me to sort of think about this initially was this noticing that current and near-term space stations, as well as not being habitats, are sort of inappropriate in terms of their scale. So I've drawn a diagram here of the ISS and the Chinese space station, both with the spacecraft that take crew to them. And next to that, to the same scale, is a Starship. So I mean, people are proposing building stations of comparable size to ISS and the Chinese space station in a world where you've got Starship. And you could potentially fit a lot more people on board that than you can on a Soyuz or a Dragon or anything like that. So there seems to be a lack of serious thinking about scaling up stations and building true habitats. So if I want to make this proposal, then we should go back and see what's been done before. And the classic study on this is the 1975 Stanford study, supported by Gerard O'Neill himself, And this is a diagram from that study. And this is their plan to create space habitat. So step one is you go to the moon. Then you mine stuff on the moon. Then you build a mass driver on the moon. Use the mass driver to send the materials to the catcher at L2. Then you use this lunar ore carrier to carry the materials from L2 to L5. Then you refine the materials. Then you build the torus. Then once the torus is fully completed, you spin the torus. Well, actually, the torus actually has a non-spinning spot. It has a radiation shield, which is non-spinning, and a spinning interior, which is, it's an iffy design choice because you don't want those things to collide. And then once you've finally got your spinning torus, you build and deploy some space-based solar power satellites to geosynchronous orbit to get back the literally trillions of dollars you've spent doing this. Profit, yay. Now, this didn't happen. There are multiple reasons this didn't happen. The entire enterprise came under unfair political attack. NASA didn't have anywhere near the kind of money to really get into it. And the whole thing hinged on the space shuttle being able to deliver cheap, reliable, and regular access to space, and it never did that. And it was realistically never going to be able to do that. But people in 1975 were kind of still thinking that it could. So fast forward a few years, there's been a lot more proposal along these lines, and some of them are sort of getting towards what I would consider feasibility. And there's a book called The High Frontier and Easier Way, which outlines one of these designs by two guys called Al Globus and Tom Mariota. Pictured is one called Kalpana 1, and they did another design which is smaller mass called Kalpana 2. So the Earth orbiting, which is what we want. We don't have to worry about transporting people to L5 and things like that. And certainly for Kalpana 2 anyway, there's no mining required. So that gets rid of the whole infrastructure of mass drivers and things like that, which is an advantage, but also it really does limit the size. Kalpana 2 is a very small habitat because it has to be launched completely from the surface of the Earth. They also wanted to go for equatorial orbit, because if you're in equatorial orbit, you're not going through the South Atlantic anomaly every orbit, or every few orbits, and you're getting, that's the big thing that dominates the radiation dose in low orbit, because they wanted to have, again, they're saving mass, they don't want to take up a load of radiation shielding, they want to have a radiation environment that is without much shielding, benign enough to raise children in. But that's a pretty stringent requirement. I mean, as soon as you get children into the picture, the radiation requirements become quite difficult. And I mentioned that's a double-edged sword here as well. As I said earlier, you want to sort of keep the option of this is a place you can depart to planetary orbits from if you want to go somewhere later. So you don't want to sort of bind yourself to one project. You get an easier time leaving from polar orbit than you will from equatorial orbit, because I'll go through the big bits of the Van Allen belts. So here's some, I mentioned the scale issue earlier. This is sort of a calculation I've done to try and illustrate what the market size for this might be. So you build a very, very large habitat so that you can fill as many people into Starship as you can safely get in there, and split the cost as much as possible between each passenger. So you want like an economy class experience to get maximum access. So here I've plotted how many passengers you're squeezing in. I've got 3 lines for 3 possible costs per flight of a Starship. You might disagree with these estimates. I think they're fairly reasonable. Possibly not the bottom one, but that's kind of the aspirational one. And this, I'm comparing it with the idea of this is people would move to this habitat because it would give them access to space. It would remove them this big barrier to entry that anyone has who wants to do sort of business or science in space of getting stuff into orbit. Because if you already live there, you can just sort of build hardware and not literally, but figuratively toss it out of the window and you're in space. So this would be an opportunity. And I want to sort of think, like, how do people currently, how much money do they invest in sort of transforming their world and sort of moving from a world of lower opportunity to a greater one. So I picked education and immigration as my examples here. So all these sort of three things are highly subscribed methods of improving your life options, and sort of they form what I think is a useful scale for what kind of costs you need to get down to. But I should note, of course, this is just the transport costs. So you need to get below this because you need to have the costs of living there, which I will get to later. So this is sort of explaining, this is the case for it to be made to government or to whoever ends up paying for it, if it's sort of charity or whatever, is we want to maximize access to space. You want to minimize the cost to go there by building a habitat and at scale. You want to allow people to stay longer, because if you have to come down every 6 months, recondition and then go back up again, then that's going to cost you a lot in launch, and it's going to be annoying. So you need the kind of gravity and radiation protection that would allow you to stay there for years. You need to allow people to stay there cheaply, so you need to be able to produce a lot of what you need on board, rather than relying on launch of supplies from the surface. Now, I did mention sort of putting mining on the critical path to building the habitat was bad, and it is, but you still want to be able to, you still want to include space mining, the whole vision that you want to bring materials to the habitat that can be used to build stuff there. So you'd imagine sort of, if you're an engineer living on this habitat, you'd be building stuff. You'd have a mixture of a few low mass items you'd ship up from Earth, and then like big sort of structural parts you'd hopefully be able to build from materials brought to the habitat from elsewhere. And this is all about removing barriers to entry, that everyone should be able to go and everyone should have a chance to participate in this sort of interplanetary economy that we expect will be emerging in 20 years or so. So the question is, how do we get to this vision? How do we sort of break it down and make it sort of, instead of just this aspiration, make it actually achievable? So this is what I'm working on with a few other people at the moment. Is instead of doing things in series, you mine the moon, you transport the stuff, you build the habitat, and you spin it up, is you take these sort of 4 tracks and you make them completely independent of each other, and you give them their own deliverables. So they just run completely independently, and then they come together at the end to actually to sort of feasibly assemble a habitat. And this hopefully makes this a bit more sellable. So I'm going to go through each in turn. So first off, mining. Now, the low mass options, such as the Kalpana 2 habitat, I don't think they're sufficient long term, because they're too small. And I know if we're looking at a sun synchronous orbit, we are going to have some radiation shielding. So it's unavoidable in the long term, but you want to be able to sort of start off without it. And the best way that I think to sort of get this done is to use what are called advanced market commitments. So you would essentially say there's an image here of the proposed Eastern Moon Village. We say, okay, we're going to be establishing a base on the moon, and we're just going to write a law saying that we'll pay X pounds per kilogram for certain commodities on the moon, and then just wait, because this will, as long as this is credibly going to be in place for decade timescales, then people will make businesses to take advantage of this, and as long as the price is high enough. And so this will create what they call sort of crowding in of investment. So the government puts some money in, and then private sector follows in with its own money. But the advantage is that you don't have to pay until you receive the commodity. So the government would not actually have to pay a penny. They could just write this this contract and just leave it there. They'd get investment into space mining essentially for free, and they'd have to pay it later on. So the idea being that you'd get investment, the economy would grow later, and then you'd be able to pay it off. Okay, so that's mining. For the second track of transport, I mean, this is what I pictured there is the sort of classic illustration of a mass driver. There are other ways to do this, and I think we don't want to be very specific. You could do a much more compact arrangement with a sling launcher, for instance. And similarly to the mining, you could possibly do this through advanced market commitments and sort of strike prices. You could just say, now we want to have this material delivered to this particular orbit, and then sort of force people to transport it. But it might be easier to do this by offering prizes for demonstrating the critical technology. And one thing that would be critical for this is that I felt was always paid less attention to in the O'Neill model, going back to the Stanford study, was that it's catching the material. Everyone knows what the mass drive looks like. No one knows there has to be this big, weird sort of magnetic catcher at the other end. And this is, I mean, they were catching at L2, where there's not really much gravity to worry about. Whereas if we want to build something in low Earth orbit that can receive materials, this stuff's going to be coming in at like 3+ kilometers per second. And you've got to shed a lot of energy, which is a much harder problem than the catchers in traditional models. So this is something that would require technology demonstration and can potentially be incentivized by prizes. So the third track is building stuff in space. The ISS is the largest thing we've built. It's 100 meters across on the long beam, and it's a prefabricated structure. And there's been some small scale experiments in other kinds of building, and the shuttle did, they built some trusses and things and tried that out. But this is still an area we don't know much about. And there's also the issue of how we control these structures, and also from the sort of the track structure, we need to have some kind of plan for construction which gets you which gets you something useful before you move on to building a full-size habitat. And what has struck me as a useful angle to go on is electrodynamic tethers. These have multiple applications. I mentioned some there. They've been tested in space. That is a picture of a 20-kilometer tether being deployed from the space shuttle in mid-90s. And there's a use for them in the space habitat design as well. I have this diagram which I drew myself, which is why it's not very good here. But if you see this little block in the middle, that's the entire space habitat. And you have these very large loops of wire around, which I'm envisioning would be able to be used as, if you put current around them in a loop and they have multiple loops, you can use them as just the same kind of magnet torque as you get on spacecraft, where you just make a moment, you push against the Earth's magnetic field, and you get rotation. That can be used to control rotation and also keep you facing towards the sun. You'd also have parts of it would operate in open mode, like this tether here, where you basically fire particles at one end and receive them at the other, and have the plasma around the Earth form part of the circuit. And what you get is kind of an ion engine that uses that plasma as a reaction mass. And this can be used to reboost the habitat, because if we're looking to build very large structures, it's going to become quite impractical to keep them in orbit with like rocket propulsion. And if you want them high enough where you don't have to worry about them, then that raises other issues in terms of things like radiation. So Yes, the final track. The final track is spinning. Where you want, I've seen a few of these companies working on space stations propose spinning stations, and they're all sort of big multi-module things. And I'm not convinced. The idea that we're looking at, I think, is to see if we can get spinning with a single launch, and that's inspired by the work that was already done in the 60s on inflatables. There were several models. It's not just this one of deployable inflatable giant tires. Really, it was literally made by the Goodyear company, which would function as sort of short radius but usable spinning stations. Now, since the 60s, we've got a lot better at building inflatables, and we've got bigger payload bearings as well, wider ones, so it makes it easier to sort of make a but this could be launched just as a sort of a national project on its own, and then we could perform the much delayed but vital research on the effect of hypogravity on humans. We could spin this to moon gravity, we could spin it to Mars gravity, and actually find out what this does to humans in the long term, because that's a very important question, and I think it's been criminally ignored by human spaceflight in most countries, in all countries. And we could also make sure we understand things like how to stabilize spinning structures with humans on board, how to dock with them, because again, I see proposals where people say, oh, we're just going to spin it down to dock with it. No, you need to be able to keep this thing spinning, because lots of things on board will only function in gravity, unless you want to sort of make everything function in both, which would be more expensive. So these things should be designed not to be despun. So you need to work out how to rendezvous and dock with a spinning station. And as I said, we should aim to do this in a single launch rather than building something big. And so the hope is that all these 4 tracks will come together to the point where we will have a feasible shot at building that habitat and providing something that will give utility to the country, that will allow our citizens access to space, and will put us among the major spacefaring nations going into the 22nd century. So that's it. I've got a few people I've been collaborating with on these ideas. I mentioned there. And one of the things I'm pitching here as well as I would like people to join me and sign this little petition I've got going. But I also want people to get in touch and offer services. So I mean, if you go back to the spinning tether structure, that was just sort of a diagram of where the wires need to go. I need a mechanical engineer to actually design, if that's feasible, as a structure. On the same thing, I would need physicists to study how it'll interact with the plasma in space, which might not be trivial. And there's a potential 5th track as well, as I mentioned, but I've not done much work on, is we need to get the closure of any life support system on such a station down a lot, also up a lot. I mean, you massively reduce the dependence on supply from Earth to make this affordable and thus accessible. So if you've got any of the skills, or if you know any group that's already working on this that we could collaborate with, then please get in touch and also sign the petition. Thank you.
Right, let's turn that off.
I can't hear anyone.
There we go. Peter, yes, fabulous. That was like loads of information there. I have a question. Specifically, you talked about basically establishing a new agency for this. And I'm kind of curious because there's so much work that went into the International Space Station right now that I don't know whether we could potentially organize in the same way to deliver that again. So I'm curious as to what your thoughts are about how we might get back to that point specifically.
By the ISS, I mean, are you talking about the way it was done at like NASA or specific agency, or are you talking about the international collaboration?
The international collaboration around the space station.
Well, that specific collaboration was basically a historical accident, because the Americans were working on Space Station Freedom through the 80s, and it was underfunded and it wasn't going that well. The Russians were working, or the Soviets were working on Mir 2, then they stopped being the Soviets and didn't have any money either. And it became this very sort of convenient thing to sort of merge two projects to sort of get Freedom to a point where it could actually fly and be usable, and also to keep a bunch of Soviet rocket scientists employed so they didn't run off to Iran and North Korea. So international collaboration in general is good, but I certainly think we should be work specifically with our European partners who are, because if we work with, I like working with the Americans as a country, but we'll always be the junior partner there. I think we do want to work with Europe on this, but at the same time, I think starting with the international collaboration might be a mistake, because as I mentioned, the ISS was formed from two fairly mature projects that sort of came together. They already had their ideas on what to do. So, yeah, obviously I would welcome any collaboration from Europe, but I think we should sort of start off the assumption that we'll just do this as a country, and then bring in the international collaboration later if there's interest.
Fabulous, thank you, Peter. Does anybody have any questions from the audience? Okay, well, I can ask another question. What do you think are the big things stopping us in terms of policy right now, and like why do you think people have so much trouble selling space into government, into the general public? Because like it should be such an easy sell, yet I don't know. My personal experience has been it's been quite difficult to sell to people.
Well, one of the things I find is you immediately hit this wall of, oh, spend it on like the poor. It's like we don't have the money, we can't spend the money, and that's part of what this campaign is that like it's asking for a massive increase in the space budget, like a huge. I think the UK Space Agency's budget is like 400 million or something. So it's like asking a 30-fold increase in it, and that would get us to just 1%. And it gives you this sort of comeback to say, people say, oh, we should spend the money on Earth, we should spend it on the NHS. You say, well, that's what the other 99% is for. So this is part of making the argument.
Yeah, understood, because I remember reading about the Apollo missions, like back when that was happening, that was still only like a single digit percentage point of the US budget at the time.
It peaked at 4% when they were like building everything out at Kennedy Space Center and doing the hard work on Saturn V. By the time the moon landing actually happened, I think it was about 2%. So like they'd done the hard spending already by the time the moon landing had happened. So they could have just carried on like 2%, no problem. But they chose not to. And it was always, there's always this angle of people coming down to Kennedy Space Center saying, oh, there's billions for space, pennies for the poor, which has always struck me as kind of a dishonest thing, because they were glossing over a factor of millions, because they're counting sort of how much each individual poor person receives, they're doing that per capita, and then they're counting the national scale expenditure on NASA. So yeah, I tend to object to that.
Fabulous, okay. So I guess my last question is specifically about the way that space is organized in this country. Because I mean, you were speaking about another agency. Like, what form might that take?
As I said, it's got to be something that's a bit more centralized and goal-driven than the UK Space Agency, or general. I'm not picking on the UK Space Agency. This is just generally how space agencies are. You have lots of different stakeholders, lots of different groups, and they all want to get resources, and they all want to get money, and you've got to sort of do a balancing act. It's just the way that science operates at the government level, and you're not going to change that, and you arguably don't necessarily want to. I mean, you wouldn't want to sort of like just kick out all the astronomers, all the planetary scientists saying, no, we're just doing a space colony now. I don't think that the two objectives of funding multiple sort of stakeholders in science and pursuing this massive long-term national project, they don't work. It's two completely separate objectives. So I think you need two organizations to do that.
Fabulous. Well, I mean, Peter, thank you so much for your time today. I'm incredibly grateful for you coming along and for giving us the benefit of your time. Thank you again. Can you get a round of applause?
Right, thank you.
So hello, welcome back. This is the last program talk of the day, and it's a retrospective on Supernova Labs. So for those that don't know, this month is the 10-year anniversary of Supernova Labs starting. So I wanted to go through what we've been through over the past 10 years and what we've learned and what might we be able to teach the sector. Yeah, Supernova Labs didn't start out as what everybody sees it today. I think it's like a lot more resolved than it definitely used to be. When I first started out, I was just sketching in my bedroom at university while I was studying physics, and just like kind of just doing little doodles and putting them up on the wall about what I wanted the shop front to look like and what I wanted how I wanted the logo to look, and like doing different designs for the logo, and it was kind of resolving slowly. I think back when it was in its initial stages, I wanted it to be like a four-corner shop where it had a bar involved with it. This is like classic university students, really, isn't it? But yeah, as time went on, the designs grew, and I was out of university in 2014, trying to find work, and couldn't find any work in the space industry. I think that's been one of the biggest drivers behind Supernova Labs starting in the first place, was that I didn't know where to go, and I was really struggling to find anybody in the Northwest that could teach me about space, or that could show me where to go to get work in space. So after a period trying and failing to enter the industry, I decided that I was going to employ myself, and that was where Supernova Labs was born. Initially, we wanted it to be a 3D printing company, so we had a lot of 3D printers around, and it was very, very early doors back in 2015. Like 3D printers, I think there were hubs for like people sharing printers with each other, but not really at the same scale we see now, where there are just low-cost 3D printers like the one in the next room just printing parts. And then at the Hackspace as well, it was still very, very early doors, which led me to Fab Labs. So we ended up speaking to somebody at a 3D printing conference about Fab Labs, and wanted to start one in Manchester. So we were working with the council for some time trying to get that started, before we ended up meeting Tony Fish and Andy Gregson from the London Fab Lab. So we ended up working at the London Fab Lab for a period of time, learning how to manage those kind of systems, and it was a great time down there. Like I don't think people really appreciate it. It was the very, very first Fab Lab in the UK, and having all the laser cutters and vinyl cutters and 3D printers there, like the kind of projects that were coming out of that were just crazy relative to anything that existed before. Like the Hackspace was available at the time, but it was a different kind of vibe. It was, yeah, slap bang in the middle of the city of London, and the kind of people that we had coming through the doors were just so like enamored by this thing that had appeared in front of them. And I think the whole building was owned by Freemasons. So yeah, it was just a really, really interesting space and a really interesting time. So after my time there, I came back to Manchester and ended up working at a place called Spaceport X. So Spaceport X was actually in the Northern Quarter, and it was a co-working space for young professionals and small companies in the tech sector in Manchester, but also had quite a large event space as part of it. So what Doug and Sean, the guys that owned it, were quite good at doing were pulling all of the Manchester user groups for different software languages. VR Manchester, was it VR Manchester at the time?
VR Manchester.
Yeah, it was VR Manchester at the time. Into this space, and it became a bit of a melting pot for ideas. And I think Spaceport X went away a while ago, but since then I've not known any space since then in Manchester that has really pulled together like people in entrepreneurship, people that are software developers, people that want to get into different fields in the same way that Spaceport X did at the time. Yeah, but we were going to build a lab there, which fell through. So I ended up going to Europe and went on to people. I started looking into digital nomading. So we ended up. I ended up hitchhiking from, where did I start out? Hamburg to Berlin to Leipzig, back to Berlin, looking through all of the fab labs around there and all the co-working spaces to get ideas for how these fab labs worked and how they didn't work. And there were some incredible ones, like there's one in Berlin at the time that was associated with a prosthetics company. So the prosthetics company was funding the fab lab, but also funded a fully licensed CNC operator. So you could, and a 5-axis mill. So you could build things in this fab lab that you couldn't build in any fab lab or hackspace in the world at that time. And yeah, it just really gave me an appreciation for the whole, like, all the different ways these could run. And hello there. But also, that was the time we started developing space planes. So I spent a lot of time sketching while I was out there, and the space plane designs kind of came out of that. Because it's one thing. Like I used to speak to a friend of mine called David Ashford about space planes, and he wrote a lot of books about the economics of space planes and how you make them work. And really, the only real way that you can do that is to run them as airliners, in the same way that traditional airlines work. Much as Peter Haig was saying before, that there becomes an inflection point where the economics work for that, around about 200 to 300 people on a space plane, where it would drive the same level of economic activity that the current airline industry does right now. And I think that's one of the primary drivers that we're focused on, that particular subject area, because I look at the way that Starship's approaching things and the way people look at rocket propulsion today, and it's typically for a few members of a particular echelon of astronauts, and space is still very inaccessible for most people. Like, it's inaccessible for everybody, mostly. And what I would like at the end of my life is to have opened up space for everyone and provided the tools for people to go to space of their own accord. It's part of the reason we've open sourced astronaut training, so we have documentation on how to train to be an astronaut, where we scraped all of the open courseware available for all the different subject areas that you would need to learn to operate yourself on the International Space Station, fix things, do orbital determination, manage guidance and control, fly the space station. And these are all the things that would feed into the kind of skill set for the future. But after I came back from Europe, I wanted to apply this. So we also initially I went down to London to run PR for blockchain companies. Because back in that kind of time, blockchain was popping off and there was lots of different companies, but nobody really knew how to talk about it because they didn't understand the technology behind it. There was lots of money in the space, but nobody knew how the whole thing worked. So I managed to get I got funding to go down there to write articles for these companies. And the industry just disappeared overnight. There was a lot of regulation that came in, and therefore the job as well. But fortunately, I'd met somebody that had a guy called Roman that put some money into building our first lab. So applying all the work that we'd learned in London, applying the co-working work we'd done in Manchester, and all the designs I've been pulling forwards. So we started our first lab in London in 2017 in Dalston. And we got our first 3D printers and laser cutters and all of the equipment you would need to build basic things. The kind of stuff that you would put in a hack space. And it's still to this day, it was the very first commercial high street space lab in the UK. We had the heads of Innovate UK coming in, and we've supported a few companies working in sort of government tech. They were trying to do like organization apps for left-wing groups, and had a lot of support from a company called HCD, the Hackney Cooperative Developments. They gave us some free space to carry on and helped us through some of the precious plastic work where we were trying to set up co-ops to do plastic recycling. But we never made any money. So one thing I've discovered about these labs is that they don't make money. The only way that I've ever seen them work is where they're partnered with universities, or if they're partnered with companies or organizations that then bankroll them to exist as a service or to their employees. So after a period of mourning, we had to shut the lab down. After a period of mourning, got back involved with Birmingham City University, building their virtual reality lab for Steam House, which was an initiative to engage the local companies in Birmingham and bring them into these kind of fab lab spaces to teach them about how to build their products or develop new product lines or engage their customers in a new way. And it was quite successful. I think they had hundreds of people through the doors, but this was over COVID, so obviously it kind of scuppered the whole thing, especially when you're trying to bring people in physically to deliver training and services to them. So yeah, again, like I think it just kind of took it out of me. So this is where Supernova Labs of today started. So right now I've completely digitized everything, and I don't believe that physical spaces really do work unless they're partnered with organizations or they're being bankrolled by other larger organizations. So we have a number of products that we are developing right now. You'll see me talk about them. I mean, you can see the Earth suit here. This is an environmental suit that we're developing for Earth. It's just a prototype right now, but we have climate control as part of the suit, networking, LoRa, Mesh-tastic networking. The helmet itself is my internet router now, so was powering the whole conference before we had to move over to Wi-Fi. But there's a headset in there, Wi-Fi. I'm going to integrate my VR headset in there so we can deliver XR as well. All towards the ends of, well, how do you have an environmental suit that can do a heads-up display and issue voice commands to the drone that you can see at the back. So this drone at the very back is fully 3D printed and uses a couple of EDF fans and has an autopilot in the loop, specifically for receiving these commands and for issuing that. Because what I'm about is integrated systems, and I want to be able to drop into the Sahara Desert and not only survive but thrive with aerial UAVs and also a survival suit, especially when you think about the way the climate crisis is going, and places in Delhi will be upwards of 60 degrees in future. There will become parts of the earth that are completely unlivable. So if we can create a solution for that now, we'll be able to save lives ahead of time. And even if people aren't buying the suit, the modules themselves only cost $3. So it's well within the range of most people's wages on Earth. So there's a couple. That's a basic history of Supernova Labs. There's a couple of things that we wanted to do today for industry, or for people that aren't in industry, such as like mapping the sector. Like as I was saying, like when I first started, I was really struggling to find any access to people in the space industry. It took me going all the way to Bremen to a space conference to meet the first people in the space industry, and they then signposted me back to the people in the UK that I needed to speak to. And it underscores the fundamental breakdown in how the space industry is marketing itself out to the general public and how it's capturing young professionals who want to move into the industry. So if I can help by mapping the sector for people, that might help. So in the northwest, specifically, there's a number of clusters. So every single person in the space industry in the UK exists as part of a cluster. There are 15 clusters all over the UK, from like northeast, northwest, etc. Ours is obviously the northwest, run by a guy called Alan Cross. There's also Bob Morris that runs the Northern Space Consortium. And Bob is the person that you need to speak to if you have anything you want to do in the North in space. He was involved with the initial UK space program back in the 1970s before it was cancelled. Other than that, you have the UK Space Agency, the Satellite Applications Catapult. They are two really good ports of call for signposting outside of just speaking to people in the industry. If you have anybody to speak to, they're the people that will tell you where to go. They are primarily based in Harwell, so I found that if you want to meet the center of the network, they're the best people to speak to. But then you have a range of facilities and science and technology councils and facilities around the UK that you can access as well. So there are people at the Advanced Manufacturing Centre in Sheffield you can speak to. There's the Science Technology Facilities Council if you want to build things and you want access to the kind of engineering equipment to test hardware that you want to send up. So typically when you're building space hardware, you want to thermally cycle it for the vacuum of space and also vacuum test it. So finding access to that outside of a university is quite difficult unless you get in touch with these people. Beyond that, looking more towards Europe, you have the European Space Agency. There's the head of the European Space Agency is a man called Joseph Ashbacher at the minute. He's very, very open to speaking to anybody that messages him or speaks to him. I found it best, like the way that ESA is structured is quite a bureaucratic organization. So you can, it's similar with most space agencies I've dealt with. So you'll often find yourself going around in circles within particular departments or within particular sectors of what the European Space Agency or the UK Space Agency is doing. So I've often found it better just to go to the head and let them direct you down. It's just a really good way of short-circuiting how that works. But yeah, so beyond that, a little bit about the maths and physics of the space sector. There's a few things that are defining what you end up doing in. Okay, let's relate it to the space plane. So, for example, with the space plane, like one of the big issues we have right now regarding sending things up to orbit is the rocket equation. So there's a thing called the tyranny of the rocket equation, which basically means that to send more mass up, you need to take more fuel with you, unless you increase the velocity of the exhaust gas from the nozzle. But people don't really talk about this because chemical propulsion tends to be, there hasn't been that much movement in it for a long time. But if you can increase the specific impulse of your engine, you get more efficiency for the amount of fuel you burn to get more mass up. And there's approaches that can do super high ISP, specific impulse engines using focused magnets and applying electricity to it, but at much smaller scales. So there are things called arc jets that people use for positioning thrusters normally on small satellites, but we're talking with a company out in Europe at the minute to expand that to the scale of a main engine, because if you can scale the ISP of a chemical engine, which is typically about 300 seconds, up to 5,000 seconds, you then get into the range of being able to build a craft the size of a car with a fuel tank in the boot, and that's enough to get you to space. Because this is ultimately the aim, and why I've built Supernova Labs is that I want everybody to be able to be an astronaut, and if we can provide the tools, the capabilities, the suits, and the vehicles for people to get there, then the future's open to anybody. I think that's crossing that gap from Earth to orbit is the gap of our lifetime. That is our Atlantic crossing, and whoever solves that commercially at a scale where the general public can just do it will open up an entirely new age of exploration and science. But there's only the way that the space industry is set up right now is not set up for that. I think we've had people in from the space industry talking about what's going on in the conference next door and how people are approaching it. And what I found is that people tend to be having the same conversations over and over and over again, and it's often always internally facing. So how do you start breaking that down, and how do you start inviting in people to the conversation that might have completely different ways of seeing how people can apply space? Typically it comes from different industries, and typically it comes from people with next to no knowledge of the space industry. Like, it's like the irony is that naivety can often breed some of the best ideas. And there's a model in tech and software that we apply with most of what we do, especially with the Open Spaceplane project, and it's applying open source. So if you can put designs out there for people to find and people to build for themselves, then they don't need to ask for permission to go and take those and make them their own and apply them in a different way, because that's all learning that you can gain from. And I think what I've found speaking to people in the industry in the past is people are very closed door and like very closed book, keeping their cards against their chest. I think it's an artifact of the military industry starting to open itself up to commercial interests and now SMEs. But how you break that down is by applying open source. So if people can find, if the designs are out there and people are applying them, you end up with a faster pace of development on your projects, because people are applying it in weird and wonderful ways and left of field applications that you might never have thought of, and that becomes use cases that then you can sell, and that's how it drives productivity development as well. So the future, I do believe the future is open source with space. It's part of, as I was saying, we've got open astronaut training. The suit design will ultimately be open source. The operating system that we're building to power everything will be open source, and because we want everybody to be able to get there and everybody to be able to power this on their own devices. Like we can't rely on people in sub-Saharan Africa and India being able to access the same technology that we have by exporting it to them. A lot of the time they find projects online and build them for themselves. So all you're doing is creating that surface area for that to happen. So the future of the space industry, I believe, is pretty bright. I wanted to do a forecast now, but it's difficult to talk about it without being a bit bleak, because a lot of the conversations that are happening over there typically surround defense and how do we remilitarize space and place weapons up there or start weaponizing the data that we already have up there, which I just think is a complete bastardization of everything that we've built for the space industry over the past 20, 30 years, especially with the International Space Station and how that broke down barriers between Russia and the West and brought together an international collaboration. Like, it just all feels in jeopardy when people are talking like this, because thoughts make things. And if people believe that this is the future, then it will ultimately be the future. So I hope to put a more positive vision for the future forwards, and one where we still subscribe to peaceful uses for outer space, and one where the spoils of this industry are distributed, because there is a lot of elitism in this industry, and it comes again from the military background, and trying to break that down for everyday people. If you cannot see yourself in an industry, then no wonder we struggle to engage with people outside of the industry, people from low income backgrounds, people from diverse life experiences. Typically, it's a constant point of conversation in these conferences about the fact that there's not enough diversity and inclusion. Oh, it's very white male and pale. If you like, but then there's not much in terms of actually trying to break that down. So moving away from defence, I think, is probably the first port of call, and running these kind of events where it's open forums for people that have never spoken about space, can speak about space and learn about space for the very first time. But then, what does the future look like for us, like in space, astronautics, and with life on orbit? I know of 7 space stations that are being developed currently. Again, much more commercial interests, but I think in 20 years' time, we'll begin to see a lot more tourists beginning to head up to space, and by the end of our lives, millions of people will be living and working in space. If we're successful with Supernova Labs and the Open Spaceplane project, kids will be trained in astronautics and piloting in schools, and it will just be part of the curriculum. And kids won't leave school wanting to drive a car. They'll leave wanting to pilot a spacecraft to orbit, and it'll be a personal or family spacecraft. And I believe that this is entirely possible within our lifetimes. Not on the trajectory we are currently on, but only if we apply open source and deliver that at scale. In terms of astronautics, yeah, astronautics will just be a requirement for a job, not the job itself. So when you have these space stations that are supporting millions of people, you're going to need baristas, you're going to need bar people, you're going to need hospitality workers, you're going to need labor and support staff. You'll be able to add 2 or 3 zeros to your wage as a result of it, because the cost of access to space is probably not going to come down by that much. And the cost of things being in space in the first place has inherent value. I think it's something that we don't talk about enough in terms of the space debris and things that are already up there. That the velocity that we have put into the boosters and the chemicals and launching them into space in the first place has value. We shouldn't be just deorbiting this stuff, because the value is there to capture and centralize and reprocess on orbit. But yeah, in terms of life on orbit, when I retire, I would like to have my own personal space station on orbit, and a little clipper that I can moor to my private space station to shuttle myself back down to Earth and up again, or just wave ride on the top of the atmosphere. I just think it would be a very beautiful future that way, and the technology is available to us. And without going too far, again, like that's borderline sci-fi. I really struggle talking about that kind of thing, because it's easy to become unmoored from the reality of where it's going. But just to wrap up, yeah, so Supernova Labs, we're trying to develop that future, and I am absolutely dogged towards it. It is my cathedral to build that, and I hope that you see, if not the final product, you see the sparks of that today. So in the Earthsuit, we're developing the operating system, the drones, space conferences. This is what Supernova Labs is and will continue to be as long as I exist, and as long as the people around me are there as well. So we're basically, this is the last talk of the Open Space Conference, and I hope that for people watching online that you've had a wonderful time and it's been insightful. You may have learned something about the space industry, and I hope it's honoured the time that the speakers have given us as well. Thank you all for coming, and I'm very, very grateful for your time and attention. Have a wonderful day. Thank you. Was any advice for young people getting into the sector? I'd say, because like there's easy advice that everybody gives. It's like, oh, speak to the UK Space Agency and like just make sure you're getting a well-paying job in it. But it depends on the future that you want to live in. So I think fundamentally, if you want to go into the space sector, you need to be able to see yourself in it first. So have big ideas about what you want to do and where you want to go and who you want to be in the future. And if moving into the space industry is part of that journey, it should be serving that, not the other way around. I think that's the fundamental thing that I've found over the years, is that the vision should be directing the actions, not the other way around. And I think that's why a lot of people in the space industry can get lost in just the day-to-day corporatism of the whole thing, and it's easy to focus on the economics and the sales and the just the actual physical things of the day-to-day, but they almost lose track of why they're there in the first place and what they're trying to deliver. So I think establishing that, writing it down, you're sat next to all my notebooks that I've been writing over the past 10 years that I was running through just then. Start writing now. Give yourself assets give your future self assets now that when you're lost in the future, you can come back to. Anybody else got any questions? Just call it a day.
You made some comments about the bringing together countries with the use of using outer space, for example. Do you believe that the Soviet Union, sorry, I still think it is the
But
Soviet
they were
Union.
the Soviet Union at the time.
Yeah, but I mean, they have their own section on the ISS,
Yeah.
which is not available to the rest of the members on board.
Yeah.
Chinese are not allowed on the ISS.
Yeah.
So what do? They build their own,
Yeah.
which in my opinion, for the short time they've had, it's absolutely stunning. The size, the capacity, the size. Whereas the ISS are sort of doing, they're doing, sorry, I've lost my voice and my hearing's gone as well. They've lost their voice. Sorry, the Chinese have built their own station. Obviously, they've had the experience of the Americans and the others, but also with Soviet help. I mean, it's absolutely brilliant. The dimensions are fantastic. It looks like a palace compared with the ISS, which is all overloaded with rubbish and junk, and it seems so organised. So, has he brought the countries together? I say no.
Okay.
For example, if it came that something went wrong with the Chinese space station, they could not, which I doubt very much if they wouldn't, get a rescue vehicle, but would the ISS jump in, or are the hatches designed all on the same, so a Soviet spacecraft can dock with the Chinese space station, and likewise. That's something you don't hear about.
Yeah, I think I think these space stations are on different orbits as well, which I think makes it a bit difficult to coordinate how to get together. But I agree. Like, there's you were saying about the fact that the Russians have their own space station, their own section of the space station that most of the people on the ISS can't access, and has it really brought all these countries together, or has it just like been like an uneasy peace? And I'd agree. I think I wish the International Space Station had gone further, because I was involved with something called the Moon Village Association at the International Space University, and they wanted to deliver something similar to the ISS on the moon, but Roscosmos was there, and the Chinese Space Agency was there. I think there's all of these things happening around the UN and around the International Space University where they're able to pull together the right people to make these things happen. But for some reason, we let politics get in the way of that. And I'm in disbelief when the economic activity and the benefit of it for just humanity has been so massive. Like, it's just been, it's given so many people visions of the future and a reason to dream. And I want to underscore what I was saying before, that it's all in jeopardy right now. And if we don't do something soon, then that vision could be lost.
And the other thing was, when man eventually set foot on the moon, the Americans, Neil Armstrong, etc., the famous "We came in peace for all mankind." Why did they not plant an Earth flag rather than the Stars and Stripes?
Yeah, that's a good question.
Telly. The answer's TV.
It's all TV.
It was all about making it look good for America. They did it, so they put the American flag
No,
on.
no, it's not.
It's about TV. It's about image.
It's all about America.
I mean, they did.
End of story. Remember, in 1941, Churchill went to America and asked for American support. It was refused. It was refused.
I don't think the British can say much about going everywhere and
It
planting
was-
flags.
it was-
That's what we did for a long
It
time.
wa- it
So everybody, thank you for coming to the Open Space Conference and for taking the time to come out today. We may run this next year. I think the overall cost of this has been about £200. 200 US dollars. I know, maybe that's like 300 US dollars then. So just to put it in perspective, like we managed to put this whole thing together in a month, and it's crazy that we've even been able to get anything together. I wouldn't have been able to do it at all without the help of people that have supported us, like John, like Rob, Anisha, Madhavi, Akash, Harvinder, like all these people that have come out of the Hackspace, the Manchester Hackspace, and from the Manchester Discord. This has been run by people in Manchester, for people in Manchester. So to put it in perspective relative to the UK Space Conference happening next door, which is a national thing. So yeah, we hope you enjoyed it. Hope you found some insight from it, and we'll see you soon. Thank you.
shooting stars. Fly by, oh. Fly by, oh. It's all about love. It's all about house music. It's all about love. It's all about house music. It's all about love. It's all about house music. It's all about love. It's all about house. It's all about house music. It's all about house. It's all about house music. It's all about house. It's all about house music. It's all about house. It's all about house music. It's all about house. It's all about house music. It's all about house. It's all about house music. It's all about house. It's all about house music. It's all about house. It's all about house music. It's all about house. It's all about house music. It's all about house. It's all about house music. It's all about house. It's all about love. 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 It's all about house music. It's all about love. It's all about house music. It's all about love. It's all about house music. It's all about love. It's all about house music. It's all about love. It's all about house. It's all about house music. It's all about house. It's all about house music. It's all about house. It's all about house music. It's all about house. It's all about house music. It's all about house. It's all about house music. It's all about house. It's all about house music. It's all about house. It's all about house music. It's all about house. It's all about house music. It's all about house. It's all about house music. It's all about house. It's all about house music. Wanna give it all.